Alright, so let's go ahead and go through our review for Unit 1B test, which is on properties of functions, inverses, and function operations. So for number 1, we first want to graph the function, and there are several ways to graph a piecewise function, which we talked about in our last unit. One way is to use a table of values, and the other is to use the slope and y-intercept. So whichever way you choose is fine. Let's first look at negative x plus 2. We want to pick values that are greater than or equal to 1, so that's going to be 1, 2, 3, etc. And 1 is going to be a closed circle because it's greater than or equal to, and then I'm going to include all the values that are greater with an arrow, line and arrow. So in this case, when x is 1, negative 1 plus 2 is 1, negative 2 plus 2 is 0, and negative 3 plus 2 is negative 1. So now I'm going to graph those points, 1, 1, 2, 0, 3, negative 1, and then I want to continue that trend to the right, which is greater than. My other function, I have 3x plus 4, and I want to start my numbers again at 1, but this time I want an open circle and everything that is less than. So numbers that are less are 0, negative 1, negative 2. So 3 times 1 is 3, plus 4 is 7. 3 times 0 is 0, plus 4 is 4. Negative 1 plus 3 is negative 3. Negative 3 plus 4 is 1. Negative 2 times 3 is negative 6. Negative 6 plus 4 is negative 2. So that was just plugging in the values. So 1, 7 is going to be up here, and then 0, 4, and then negative 1, 1, and negative 2, negative 2, and then continuing that pattern. My domain is looking from left to right. So when I look to the left, I notice that this function is going to continue to the left. I'm not going to have any breaks in the graph because here I have a value at 1, and this is going to continue to the right. So my domain is going to be all real numbers or from negative infinity to infinity. So where does it start? Where does it stop? My range, I don't know where this is going to continue down to, so my range is going to start at negative infinity. However, this graph only goes up to 7. So therefore, 7 is the cap, and I'm going to not include 7. So that would mean that I'm going to use a curved parenthesis. It is not continuous because when I trace this function from left to right, I have to pick my pencil up to come down to this function. So it is no. There is a maximum value. It's an open circle. We'll talk about that more, but 7 is fine. There is no minimum because this is going to keep going down and you can't count to infinity. So we're just going to say none. This is increasing, and this is decreasing. And again, it's from left to right. And for increasing and decreasing intervals, you want to look to the domain. So this is your x values. This is according to x. So it's increasing from the x value of negative infinity because you don't know where this function starts, and it increases all the way up to the x value of 1. So from negative infinity to 1, and we don't want to include 1 because it's an open circle. Decreasing starts at 1, but that's a closed circle or a solid dot, and then it keeps going to positive infinity because it starts here and it goes to the right. It keeps going to the right to positive infinity. It is not one-to-one because it fails the horizontal line test. And your axis of symmetry, there is none because this is not a absolute value. Alright, looking at our next function, this is a absolute value. So therefore, I know that it's going to be written, it's going to be a V-graph, so I'm going to have to identify that vertex. So the vertex of this graph is at 2, the opposite of negative 2, which is 2, and then you keep the negative 4. So 2, negative 4. I'm then going to use my slope of up 1 over 2 to graph the next 2 points in both directions, and then complete my graph. My domain is going to be all real numbers because this is going to keep going left and this is going to keep going right, so from negative infinity to infinity. Your range is going to start at negative 4 and including negative 4. It starts here, and then it's going to continue up, so that's up to infinity. It is continuous because you can trace the function from start to finish without picking up your pencil. There is no maximum because there's no highest point. And notice that corresponds with the infinity. So none, range is infinity. Minimum is at -4, which happens to be my lowest range value, which that's always going to happen. Okay, same reason why it happened over here. It is increasing here from left to right. It is decreasing on this side. So where does it increase? It increases from the x value of 2, and it's going to keep going to the right. So from 2, including 2, all the way up to infinity. It's going to decrease from negative infinity. Remember, this is negative infinity. So it's going to decrease from negative infinity all the way to the 2. So it's going to increase from negative infinity all the way to the x value of 2. And include 2 there too. It is not one-to-one because it fails the horizontal line test. And your axis of symmetry is where do you have that line of symmetry, which on this graph happens to go right through here. So you have that mirror on both sides. Okay, it always goes through the vertex on an absolute value. And notice that's the x value of 2, and you have to write it as an equation. X equals 2. Okay, looking at number 3 and 4, and this should say the absolute value of x plus 3. X minus 3, excuse me. And then plus 4. So again, this is an absolute value equation. So my vertex is the opposite of the inside, which is going to be 3, 4. So I'm going to go over 3, up 4. And then I'm going to use my slope of just up 1 over 1 because there is no number before the absolute value. Domain, all real numbers, so from negative infinity to infinity. My range is going to start at 4, including, and go to positive infinity. It is continuous. There is no maximum, again corresponding with the range of infinity. The minimum is at 4, same again corresponding with the 4. Increasing and decreasing, so this is decreasing again, just like our other one. This is increasing. So decreasing, or it is increasing from the x value of 3 and keeps going to the right. So from 3 to infinity. It is decreasing from negative infinity to the x value of 3. Inclusive. It is not one-to-one because it fails the horizontal line test. And you have the same axis of symmetry as before, as x equals the x value of the vertex, which is 3. Another piecewise function, you can do a table of values, x and y. X and y. So in this function, you want to pick numbers that are less than or equal to 3. So it would be 3, 2, 1. And again, it's going to be a solid dot, and then the values that are less. So when I plug in 3 to this function, negative 2 times 3 is negative 6. Negative 6 plus 4 is negative 2. 2 times negative 2 is negative 4 plus 4 is 0. And 1 times negative 2 is negative 2 plus 4 is 2. For the x value of 2/5 x plus 2, you're going to probably want to pick some values here that are going to be multiples of 5, just to kind of make it easier on yourself. So if you pick negative 5, 0, and 5, or you could plug this in your calculator and see the behavior. But you are going to want that value of x value of 3 in there. So one thing I would suggest is to, instead of picking negative 5, maybe we will start with 3 instead. See what we get for that one, because we do want numbers that are greater than 3. So then you could pick like 3 and 10 and see what you get. You really don't need 3 values. So 3 times 2 is 6, and then 6/5 plus 2 is going to be 3 and 1/5. So you are going to get a fraction for that one. When x is 10, 10 times 2 is 20. 20 divided by 5 is 4. 4 plus 2 is 6. So let's graph those 2 points. You need that point at 3 though. So 3 and then 1, 2, 3 and 1/5 is going to be here with an open circle. And then 10, 6, you're going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is going to be all the way out here, and then up 6 is going to be somewhere over here. So it's actually going to kind of go off the graph a little bit. That's all right. Okay. So there's your first, and then when you graph these points, 3, -2 is a closed circle, and then 2, 0, and then 1, 2 is going to look like this, and it's going to continue up in that direction. So this is your piecewise function number 4. Domain, again, is going to be all real numbers from -infinity, because one function is going to keep going left, and this function is going to keep going right. Your range, it doesn't start, it starts at -2, including -2, and goes all the way up. Both of these graphs are going to keep going up, so from -2 to infinity. It is not continuous, because you cannot trace the function from one end to the other. It does not have a maximum value, and again corresponds with that range value. The minimum value is at -2. It is increasing from 3 to infinity. So you're going to, again, open interval from 3 to infinity because of the open circle. There we go, 3 to infinity. Decreasing here from -infinity to 3. And this time you do want to include 3, so that's where you're going to use the square bracket. It is not one-to-one because it fails the horizontal line test, and there is no axis of symmetry. Alright, moving on. Again, this is a linear function. Graph a linear function, you're going to graph the y-intercept. Go up 1, 2, 3 over 1, 2, 3, 4. 1, 2, 3, oh, sorry, one more. 1, 2, 3, 4. And then you're going to draw a line through those points. See if I can get my line straight here through the points. Okay. Alright, and since this is a linear function, domain is always all real numbers. Range is always all real numbers. It is always continuous. There is no min or max. This function is always increasing, so therefore it's going to increase from -infinity to infinity. It is going to decrease never, so there is no decreasing interval. It is one-to-one because it passes horizontal and vertical, and it has no axis of symmetry. Okay, so this wraps up properties of functions. See the next video for function operations and composition.